Okay, we'll make it big now, I guess. Okay. Okay, so now we have 7.2 division property of exponents. So we just did multiplication property of exponents. Now we're going to do the division ones. Okay. So the first property, there's 4 in this one, but one of them super easy. Now the first one is called the quotient of powers. Okay, so we just talked about the product of powers, and we're talking about the quotient of powers. This one is a to the m power divided by a to the p power. Okay, what we do, so when we multiplied whole numbers, what do we do with our exponents? We added them. So when we divide whole numbers, what do you think we're going to do with our exponents? Subtract them. So you're going to do a to the m minus p. Okay? We're going to put a little asterisk. I'll put a little star because I can't draw the asterisk really well. A little important thing to go with this. Always subtract largest minus the smallest. That should be common sense. And put your answer in the location that the largest started. And I'll show you right now what that means. So these ones I'm going to show you, we're going to do the practice problems together at the same, like after that, so we don't get confused. Okay, now write down this example right here. Example 1, x to the third power times y to the fourth power divided by x to the second power times y. So you have x and y on top, x and y on the bottom, okay? Now, we're going to do these as we go because the division ones get a little confusing. Now, what you do is you first just pick one at a time. So look at the x's. Which number is larger, the 3 or the 2? 3, right? So we're going to do 3 minus 2. If I do 3 minus 2, how many x's are left over? 1. And then you put, so that's what this little note that we just wrote down. And then it says, put your answer in the location the biggest started. So you see how x to the third was on the top of the equation? We're going to put our answer of x to the first. You don't have to put the first if you don't want. Like if we had a fraction, it would be on top of the fraction. So your answer goes wherever the largest power started for that variable. Does that make sense? Then we look at the y's. We have y to the fourth up here, and then what does this y have a power of? 1, technically. So then we do biggest minus smallest. What's the big number minus the small number? 3. Where's my answer going to go? On top. So y to the third. Then technically we wouldn't need a fraction. If you really want to, you can also put it over 1. Both are acceptable. We're going to do all 3 of these examples. I'm going to change this example because I don't like it. Okay. Now number 2. We have k to the 7, m to the 10th, a p. K to the 5th, m to the 3rd, a p. I always just draw a line. Look at the k's first. When you do biggest amount of k's minus smallest amount of k's, how many is left over? 2. Where's it going to go? On top. K squared on top. Okay, what about the m's? How many be left over? And where's it going to go? On top. Okay, right now we're all on top. What about the p's? There isn't a biggest number, is it? They're the same. What happens when you have something minus itself? It cancels out. So the reason you do biggest minus smallest is because we could, if we really wanted to, this would take so much time. 7Ks, we can go, okay, K. We could put 7Ks on top and then 5Ks on the bottom and then cancel out the ones that are in common. That just takes a lot of work. Why do that when we can subtract? If they're the same, you go, okay, 1P minus 1P. What's 1 minus 1? It's 0. That means we have no P's left. So will there be any P's in my answer? Nope, that's it. That's just your answer. Now try this one. 3, your answers are in different locations this time. So you have x to the 7th, y to the 3rd on top. I changed it. And then x to the 6th, y to the 12th on the bottom. So how many x's will be left over and where will it be? One x on top, so I'm just going to put an x up there. What about the y's? 9 and on the bottom, so y to the 9th on the bottom, right? So it does make a big difference. So we have to pay attention because when a lot of variables happen, you want to do one at a time. Okay? Does that make sense? Does that property make sense to us? Okay. Let's go back up here. For you, you can just put them in order. I'm just going back and forth. Now we'll do the power of a quotient. Okay. So that is if we had a fraction. We're always going to have fractions for this one. A over B in parentheses, all to the m power. What you think's going to happen? What did we just do last section when there was a power on the outside of a bunch of stuff? We distribute to everything. So this same rules applies whether it's a fraction or a bunch of numbers left to right. So this is going to be a to the m power over b to the m power. So this m has to go to everything, whether it's on top of fraction, bottom of fraction, left of fraction, right to fraction. It does not matter. It has to go to everything that's inside that parentheses, no matter what. And then we would simplify if we need to. So then that's where we come with these 3 examples. So we have 4, 5, and 6. Now we can look at. So let's look at 4. Inside the parentheses, you have 3p to the 3rd all over 7. All of it is being squared. So what are we going to do first? What are we going to do first with that problem? Ooh, no. This 2 is a power. Show that you're going to put it with every number and every variable in its power. You see how I went to 3 different things, the 3, the p to the 3rd, and the 7. So sometimes, especially with fractions, it does help to rewrite it. So 3 squared. Now p we can rewrite. What's p going to be to the power of? 6. And then 7 squared. Now can we reduce those whole numbers? P is still going to be to the 6th. But what's 3 squared? 9. And what's 7 squared? 49. So this guy right here would actually be our final answer. Now, if it could simplify, we would simplify it, but 9 over 49 cannot be simplified. And the reason we know that is because the original 2 numbers, 3 and 7, they have nothing in common, which means when we make them bigger, they still have nothing in common. Okay? So let's try 5. Just like that one, just different numbers. So 3x to the 4th all over 4. all in parentheses, to the third power. Oh man, again. Again, what are we going to do with that 3 on the outside in the power? We're going to distribute. I think it's 64. Right? Okay. Did we get the same answer? Did you get the same answer as me? Mine's down here. That was a 12. Do we all get that? Does that make sense? Okay, let's scoot. This is as far as scoot as I can go. This last problem 6. Now we have variables on top and bottom and numbers on top of them. Just an extra little thing added. That's all. So try that one. See if you get the answer I'm going to write down. Oh, I'm going to have to write down here because you won't be able to see to the side. Did we get the same answer? Yeah? It's not so bad. You thought it was going to be scarier than it was, didn't you? Okay, we're doing good. Okay, third property, 0 exponent property. This is a fun one. Okay, now this one seems a little silly at first. So the 0 exponent property means anytime we have a power of 0, like a to the 0 power, or 52 to the 0 power, they always equal the same answer no matter what it is. Anything, and I do mean anything, to the 0 power is the whole number 1. So if it's only connected to one variable, it cancels out that variable. If it's connected to a whole big group of things, that whole thing is canceled out to make just one. It's really that easy. So we come down here to number 7. You look at this guy, you go, I got x's and I got some y. So the x's we treat by going, this says division. When we divide numbers, we subtract their exponents. I have 5 x's and 3 x's. What's 5 minus 3? 2. It's going to stay on top, right? What happens with that y? Turns into a 1. Do I have to write 1 times something? Nope. That guy right here, that 2, that x is 2, that's it. He's more on the answer. It's that simple. Done. That's it. Zip. 0. Zilch. Now 8 has a little bit more. It's got some B's, got some C's, and a D. That D looks interesting. Can we simplify this guy? Oh, I'm struggling with the lead today. Ooh, just fell out. Okay. So my B's, what I got? Where's it going to be? On top, B second. What about C's? Just C, also on top. What about D? Nothing, he's gone. He turns into 1. That's it. Okay, now that big mamma jam. I don't know if you can see him. Hold on, there you go. We'll zoom in. Oh, there you go. I'm struggling a little bit with this thing. There we go. Number 9. I'm holding it up so you can see it. Look at this big old mamma jamma right there. Maybe write him down. Look at him. He's a big guy. He's got a lot going on in him. The real question is, can you figure out his answer without breaking a sweat? That is the big question. 2, F to the 4th, G to the 7th, H to the 3rd all on top. 15, F to the 3rd, G to the 9th, H to the 6th all on the bottom, all in the parentheses, and there's a 0. The question is, do you know the answer already? That is the real question. Do you know the answer? The answer is 1. You don't have to do any math. Why is the answer 1, Lexi? When it's all to the 0 power, and you're like, I could distribute this, but when I distribute it, it's all 0. Anything all to the 0 power is just the whole number 1. So I just write equals 1. What? Hello. I do. Okie dokie, thank you. Bye. Remember, you gotta pick something up in the office before you leave. Yes, before you leave, pick something up in the office. Okay. Now, time to learn the last property. Then we'll mix them all together. Okay. Negative exponent property is exactly how it sounds. It's got negative exponents, okay? This is how this works. I'll show you both forms. So if you have, well, zoom in a little bit. There we go. You have a to the negative n power. That is not allowed. One of our many rules in mathematics, right? I know you love them. Are your exponents cannot be negative. It is against the law. Okay? So how we stop that is we rewrite this as its inverse. So a to the negative 1 is really a to the negative n over 1. So we flip it. When you flip over this line, or in the most darkest way I can ever think possible to tell you, when you cross over to the side and we all die one day, you have to be positive when you go into the light. So when you cross over the line, go into the light, a has to be positive. So now it's a to the positive n. You'll never forget that now because it's the most cryptic thing I've ever told you in your entire lives. Same thing goes if it starts on the bottom. So if I start with, I'm going to write or 1 over a to the negative n. Actually, let's change that 1 to a 4, okay? Just to make it interesting. Okay? You leave the 4 alone. He has nothing to do with that negative. Leave him alone. But this negative, guys, not allowed to happen. So he needs to cross over to the other side to be positive. Only the thing that's connected to that negative exponent can move. So the 4 stays up top, and a turns to the positive n. Now it's all over 1 because there was nothing left underneath with that a sub n. Does that make sense? In a weird, cryptic way. You'll never forget it now. I know. Okay. So now all of these problems have negatives in one form or another. How I like to deal with negatives is I like to leave them until the very end, ladies and gentlemen. I do not like to deal with that negative sign. I'm scooted until I am done simplifying variables. So look at number 10. It says n to the negative 5th, p to the 4th, all over r to the negative 2nd. And that may not be able to see that negative. That's why I said it. Okay? Now, before you even think about dealing with negatives, you want to deal with every other property there possibly is, which means if you have multiple n's or multiple p's or anything, you would deal with it. Are there multiples of any variables here? No. Okay, so the only option is to deal with the negatives. So this is how I mark it. I go oh, this guy is negative, so I'm going to circle him. And he's on top, so I draw a little arrow and go, he needs to be down here. He needs to cross over. This P to the 4th, he's beautiful, happy, positive guy. He's going to stay right there. Then I'm going to come down to the bottom, look at him and go, oh, this guy's negative 2, so I'm going to circle him. But since he's on the bottom, I'm going to draw an arrow that says, he needs to cross over, but he's going to be up top now. He's lucky. So if you circle and show what things are going, you can see it. So that when I write my answer, I go, okay, I still got a fraction. What's the thing that stayed up there? P to the 4th. That guy, he circled, but he moved down. So he moved down here. N to the positive 5th now. And that R to the 2nd, it is now positive and up top. Does that catch your mind? You make sense. You're getting the pieces together. You awake over there, Tristan? Okay. So now we're going to throw in some doubles. Now, is a negative number and a negative exponent the same thing? Is it? No, it's not. You leave that 20 alone. He did not do anything to you. Okay? So write the problem down. You have 5 r to the negative 3rd, p to the 4th, all over negative 20. That number itself is negative, not its power. R to the 2nd, t to the 7th, u to the negative 5th. That looks like a W. We'll fix that. Okay. Now, left to right, always deal with numbers, then variables. So the number 5 over negative 20, can that be simplified, aka, or reduced, that fraction, 5 over 20? Or you ask yourself this, can the number 20 be divided by 5? Negative 20 cannot be divided by 5? What's the answer? 4. Where was 20, on the top or the bottom? Where do you think the number 4 is going to be? On the bottom. It's just like dividing, man. It's just the same thing. I wrote the same problem twice for 11 and 12. Oh, boy. So negative 4 stays on the bottom. Okay. Now, look at your R's. You could deal with that negative or use your subtraction rules. Which one's bigger, 2 or negative 3? 2. So what is 2 minus negative 3? 2 minus negative 3. Positive or negative? Positive 5. Where's that 5 going to go? On the top or the bottom? Bottom, because that's where the 2 was. Look, so now you already dealt with that one negative. Beautiful. Okay, T's. You got multiple T's. Which one's larger? 7. When you do the subtraction, what do you get? Where's it going to go? Bottom again. We're real bottom heavy right now. Then we got this u to the negative 5th. So you got anybody to add with? No, so I'm going to circle them and say, I want you to be happy and positive. We're going to scoot you up top. Just draw a little arrow. And then what am I going to do? I'm just going to write him. U to the positive 5th up top. Does that make sense? You catching what I'm throwing down? How you doing over there, Kimber? I missed your hiccups. My life's been too quiet without them. Okay, well, I am a silly Billy, and I wrote 11 down twice, so my number 12 is the same as 11, so that was my bad. So your numbers are going to now be off from mine. I'm sorry. Okay, my 13 here, 12, is v to the negative 3rd, w, x squared, all over w, y to the negative 6th. So friendly hooligans, what are we going to do first? I just move left to right. So if you can't think about which one comes first in the alphabet, you can always just move left to right. The W's would cross out because you have a W on top and W. There's only one of each, so they just cancel out. That's nice. And then can anything else combine together? So what are we going to do with all that stuff? We're just going to say where they go, aren't they? We'll go, this v to the 3rd, need him to be happy. Going to move him to the other side. What else needs to move to the other side? y to the negative 6. We want him to be happy and positive too, so he's going to go to the top. So what is my final answer going to be in fraction? Correct. Good job. Okay, so now you can see my silly mistake. Okay. We'll just cross that out like he never happened. There we go. Okay, now I'm gonna freeze that so the lines stop. Uh-oh. Uh-uh. So those are your last two problems on this page. Try them out, see if you can simplify them. That is a 32. It might look like a 7 from over here with my eyeballs, so it's a 32. So it's 32, a to the negative 8, b to the third, c to the negative fourth, all over 4, a to the third, b to the fifth, c to the negative second. And I'm going to pick 2 of you, and you get to do it on the other board. Oh, don't you dare. Now my real question is, did you guys eat all those suckers I gave you already? That's impressive.